Gosh, Brooklyn, you're so mean.
No, I know. It's just upsetting.
I know it's pretty bad. What?
Here's older, it's like, well, if you guys want to find it, it's pretty simple. Oh, wait, what is that?
Yeah, hey, I should go get it.
I'll give you like a plastic one. Oh, hey, thank you.
All right, guys. I believe this is where we left off yesterday, yes? And I think we typed this one into the graphing calculator already. Y equals 6x to the fourth minus 11x to the third minus 16x squared plus 2x plus 4. Yes. And we graphed it. Well, it does cross the x-axis in 4 places, but none of them are integers. They're not nice numbers. Now, they are somewhat nice because at least 2 of them are rational, fractional answers, but we don't have any non-decimal, non-fractional answers. So, what that means for us here is we're going to have to find the rational zeros.
What number are we on?
We're on the...
Oh, no.
Next one.
Oh.
No, right there. So, plus or minus p over q. So we're going to find the rational zeros. And what we're hoping to find with the rational zeros is at least 2. Because if we can find 2 solutions with our rational zeros, we can take it from a degree 4 down to a degree 2. Right 3. But down to a degree 2. Because if we find 1, it will take it from a degree 4 to a degree 3. We find a second from 3 to 2. If we find a third, that'd be even better, because it would take it down to a degree 1, which is just a linear. So an x term and then some number. I have a number equals c. We just solve for x, which is even better than a quadratic. In the best case, even better than that, is if we find 4. Because if we find 4, we found them all and we are done. Now, here, rational zeros. P, factors of P is the factors of the constant term, our term without a variable, which is 4. Well, first set of factors of 4 are 1 and 4. The other are 2 and 2. Now, we're only going to list it once. Because if you remember back to yesterday when we listed out the factors for this here, if any of them repeat more than once, we only list them once. So having 2 twice for the factors of P is not going to give us anything more than 1 would. So we only list it once. Factors of Q. Factors are the term, the number in front of the variable with the biggest exponent, which is 6. So we have 1 and 6 and 2 and 3. Questions on how we found this here? Now the next part, we're going to take all the factors of P and divide it by each factor of Q. And we will have the plus or minus. So our first one is going to be plus or minus 1 divided by 1. And then we'll have 2 divided by 1. And then 4 divided by 1. 4. And it is going to work out that we're going to have plus or minus just all the factors of p, because when we divide by 1, we just get that number back. Questions on this here? Well, now we move on to q being 2. So we have 1 divided by 2, which is 1/2. 1/2 is not listed. Then we're going to move on to the next one. 2 divided by 2. 1, is it listed? Yeah, we don't have to write it twice. And then 4 divided by 2 is? We already have it, so we don't have to list it again. Then we can move on to 3. So our first one would be plus or minus 1/3. 2 over 3, plus or minus 2/3. And lastly, 4 over 3 would be 4/3. It is 1 1/3. I normally leave it just as 4/3. Purple. Last one we have is 6. So we have the first one is plus or minus 1/6. 2 over 6. 1/3. We already have it. 4/6 would be 2/3. We already have it. So these are all the factors we have. Now we have 1, 2, 3, 4, 5, 6, 7, 8. And with the negative cases, we have 16. Just the number of, yeah, because I just counted them individually. But as positive and negative cases, we actually have 2, 4, 6, 8, 10, 12, 14, 16. So we have 16 possible rational zeros. Now, that's not all the solutions because we have irrational and our imaginary, our complex answers. But if this has rational solutions, it is listed here. Now, as we already saw, positive -1, positive -2, positive -4, do any of those values give us a y value of 0? No. So, well, this color here, those are all gone. So when we typed it in and did second graph, we looked at the table. Because if it's a solution, the y value must be 0. At -4, the y value is not 0. At -2, the y value is not 0. At -1, the y. And graphed it. And here, looking at the table, well, we can see 1, 2, 4, -1, -2, -4. None of them give us a y value of 0, so they're automatically gone. So now we're looking at just our fractional answers. We can do that, and we'll pick those values. But what we can also look at is the graph itself. Each time it crosses the x-axis, so actually crosses, it has an odd number of solutions. Here we're going to have 4, and it does cross 4 times, so each one of those spots is only going to have 1 0, one value there. Well, so there's 2 right here. It's just they're very close to each other. This one, the farthest to the right, is the biggest one value we could have, yes? It's between, what, 1, 2, and 3, yes? Do we have any rational 0 that's bigger than 2? Yeah. Well, that's between 0 and 1, 0, 1, 0, 1, 1 and 2, 0 and 1, yes? So most likely, that one to the farthest to the right is not going to be rational. It's most likely going to be irrational. So we can count that out. But the rest of them are between 0 and -1 or 0 and 1. Because each one of these little dash marks is 1. So we're really looking between -1 and 1, yes? Is 4/3 between?
No.
No. So that one is out. So we've just taken another 2 out. 1, 2, 3, 4, 5, 6, 7, 8. We have 8 left to check. So 4/3 is 1 1/3, yes? On the graph, that would be either here or between those two, yes? Do we have a spot where this graph crosses in those two regions? Nope. No, it's not even a choice. Now I could check it if I wanted to. Second trace value, 4 divided by 3. We get a y value that is not 0. I can go second trace negative 4/3. And again, we have a y value that is not 0. So we can try the others. Pick one of those. 1/2. Positive or negative 1/2? Positive. Value 1 divided by 2. And we get a y value of 0. So is it a solution? Yeah, because we're trying to find what values of x will make the y value be 0. Now, is there any other positive ones? Well, no, because we found the only positive one here, yes? Because the other one's too big. So that's helpful in a number of ways. One, it tells us that x is indeed 1/2, yes? Could any of the other positive ones work? Well, no, because the one's way too big, and we found the only other one. Now, I could show you that here, because I could go second trace value positive 1/3, not 0. Second trace value 2/3, not 0. Second trace value, yes. Yep. So the rest don't work as positives. But they could work as their negatives. Second trace, negative 1/2. No. Second trace value, negative 1/3. No. Second trace value, negative 2/3. And negative 1/6 won't work either. Partially because since we said that the one to the farthest to the right was most likely going to be irrational, irrational solutions come in pairs. So we found 2, the other 2 are going to be irrational. So, yeah. 6, negative 11, negative 16, 2, 4, bring down the 6. And again, for the most part, I would do this in the calculator. Normally when I do these here in the calculator, I use the 30xs to do synthetic division because I'm just typing them in. So I'd say 1/2 times 6 is 3. Then you could hit plus negative 11, which is, then we can say times 1/2 plus negative 16. Negative 20 times 1/2 plus 2 times 1/2 plus 4 is 0. So doing these, just the addition, multiplication, addition/subtraction, and multiplication in the calculator will make them run a little bit quicker, a little bit easier, a little bit faster. And I'm not expecting you to do these in your head. Now, negative 2/3 times 6 is negative 4. Negative 8 plus negative 4 is negative 12. Negative 2/3 times negative 12 is negative 8. Sure, no, it's positive 8. Positive 8. And negative 20 plus 8 is negative 12. Negative 2/3 times negative 12 is 8. And then we get 0. Questions on this here? Now at this point here, we do need to put the variables back in. So the last 0 is our remainder. First negative 12 is our term without x. The second negative 12 is our term with x. And 6 is our term with x squared. So what we have left is 6x squared minus 12x minus 12 is equal to 0. Is there a common factor, a number common factor? 2 is, but 6 is bigger. And it works on all these here. Now, pulling this greatest common factor out won't eliminate the possibility of there still being one, but it does reduce it lower, your chance of it lower. Because since there was a greatest common factor of 6, we were guaranteed to have one. Now we decrease that possibility. Yes. Question? Okay.
I'm sorry for being
She was like running to the bathroom. Running to the bathroom. Is that
AC. Have a tendency to drag the pen. So negative b plus or minus the square root of b squared minus 4ac. Yes. Because we have two of the solutions. One of them is our 1/2. The other is our negative 2/3. We're just trying to find the other two. So we're going to use the quadratic formula on this here. Negative minus 4ac all over 2a. Now a in our case is 1, because a is the term in front of x squared. B is negative 2, and c is negative 2. Questions on how we found a, b, c?
Oh, wait. It's just either one.
Yeah. Because otherwise it would have been 6, negative 12, and negative 12. So we could plug in the value of b, so negative b would be negative negative 2. Inside the radical, b squared would be negative 2 squared. Minus 4 times a, so times 1, times c, 2, all over 2a. Now our negative negative 2 is positive 2. The denominator, 2 times 1 is 2. Inside the radical, I just plug it into the calculator. Negative 2 squared minus 4 times 1 times negative 2 is 12. Now we can take the square root of 12. We'll need to use the 30xs instead of the graphing calculator. Graphing calculator will just give us a decimal. Reduced radical form is 2 p squared of 3. Is 2 and 2 squared of 3 divisible by 2? Our denominator. 2 divided by 2.
Oh.
2 square root of 3 divided by 2. Well, the 2 divided by 2 is just the square root of.
3. Oh.
because the 2 and 2 become 1. 1 times r squared of 3 is just the square root of 3.
Where did it go? Where did they go? Oh, you divided.
Yeah, because we're going to say that this is 2 over 2 plus or minus 2 square root of 3 over 2. 2 divided by 2 is 1.
So it's like 2 plus or minus 2. So it's the first 2 here.
Yeah, so this first 2 over 2 becomes, well, we split it up as 2 fractions.
Where'd the other one go?
Here,
Oh, I get it. So the first 2 are getting divided, and it has its own thing.
Yep.
Divided by 2.
and then the other ones,
Divided.
so the 2's right. We're saying they're both divided by 2.
But this is
Well, their 2 over 2 is,
but this is
and 1 times the square root of 3 is square root of 3, yeah. So it kind of does and kind of doesn't.
I just asked that. Sorry.
Which
There's 3 2's, and I'm only seeing where 2 of them go.
This 2 is here, and a, well, it's not 2, it's a. If I did 1/3 plus 2/3, this would be the same as what? 1 plus 2 over 3, yes? If we go backwards, well, we know we split it up into 3's, go on bottom, yes? Same thing here. So the 2 at the bottom is applied to both, and we can simplify down.
Okay.
Yeah. So here we have 2 answers, and this is our other 2. So we have a total of one more, 4. Yep. Yes. Questions on this here? So with all these here, we really lean on the graphing calculator first to find as many solutions as possible. Here, it turned out we didn't find any immediately, so we used the rational zeros in the graph to kind of help us figure out at least 2. We got those 2, used synthetic division to reduce it down to a quadratic, and then we solve from there. Questions on this here? Let's do one more before we move on. Yes. X cubed minus 5x squared minus 2x plus 24. X cubed by x squared. It's minus 2x, correct?
Yeah.
Yeah. We have this graph here. Careful.
Oh, are we on a different one? Oh, yeah.
X cubed. So I know that y'all are pretty comfortable with getting these typed in, but if we look at the table with this one here, what values of x make the y value be 0?
4, 3,
And
2.
now, since this is a cubic, we need at least 1 to get it to a quadratic, 2 to get to a linear, and we need 3 to finish solving, yes? How many do we have? We're done. Yeah. Questions on this here? Last theorem of 2, 5, or 4, 5 is this here. So this here is the last theorem we have for 4.5, and it's the irrational conjugates theorem. You don't have to write the whole thing out. I wouldn't write the whole thing out. What this theorem states is that if a plus the square root of b is a solution, then a minus the square root of b is also. If we have one, we have to have the other. So if 2 plus the square root of 2 is a solution, 2 minus the square root of 2 is a solution. They always come in pairs. Also means that if the square root of 7 is a solution, negative square root of 7 is a solution. If we have one, we have to have the other. Kind of this is the same as with complex numbers. If I have 2i as a solution, negative 2i is also a solution. Complex conjugate theorem. We will have that in 4-6. But if we have... Yeah, if we have one, we have to have the other. They have to come in pairs. That's also why on that, not the last one, but the one before it, why as soon as we got 2, I knew we would have 2 irrational pair, an irrational pair. If we got one, we have to have the other. Okay. So here, we want to write a polynomial function of at least degree that has the rational coefficients. There's rational coefficients, the leading coefficient of 1. So the zeros are 3 and 2 plus square root of 5. Now, what we're doing here is kind of the opposite of what we've been doing so far today. Because so far today, we've been given the polynomial function, we want to find its solutions. Now we've been given the solutions, and we want to find its polynomial function. We're going the other way around. Now, since 2 plus the square root of 5 is a solution, is also a solution. Okay. First step, we're going to get all these equal to 0. We're going to get the terms on the same side. So here, we're going to subtract 3. Minus x minus 3 is equal to 0. Okay, that one's done. The next one we can, minus 2 first. Telling us x minus 2 is equal to, now we will need to minus square root of 5. Telling us that we have x minus 2 minus square root of 5 is 0. Last one. So x minus 2 is equal to negative square root of 5. Now we would add square root of 5. Well, if you notice with the two conjugates, they're pretty much the same except the sign in front of the radical. Questions on how we got to this here? We good with this here so far? Nope. You're going to have to write over the top of the next one. Because, no, you've run out of room. You're good. We're not going to do that one anyways. So, next step, we multiply them together. Next thing we're going to do is we're going to multiply them all together. So we're going to multiply the x minus 3, the x minus 2 minus the square root of 5, and our x minus 2 plus the square root of 5. We really don't need the equal 0 anymore because we're more focused on the polynomial, not trying to solve it. We did the minus 0 originally just to get our setup, our factors. And now we're going to multiply this here. Now, the order in which we multiply it does and doesn't really matter. We can do the x minus 3 times our x minus 2 minus the square root of 5. I would advise against that. I would do the conjugates first. Our x minus 2, so our ones that have the radicals, our same radicals, let's do them first. Always do them first. Now, if there's others, you can do them. So our x times x is x squared. Our x times negative 2. And our x times the square root of 5 is plus x square root of 5. I'll switch colors. Now we're going to do it with negative 2. Negative 2 times x is negative 2x. Negative 2 times negative 2 plus 4. And negative 2 times square root of 5 is negative 2 square root of 5. Negative square root of 5 times x is negative x square root of 5. Negative square root of 5 times negative 2 is going to be plus 2 square root of 5. And lastly, negative square root of 5 times square root of 5 is going to be negative square root of 5 squared, which is just 5. For square root of 5? Yeah. Square root of 5 times square root of 5, it will simplify it to 5. Because our 5 times 5 is 25. What's the square root of 25? Now, if we look at this here, yeah, x squared doesn't have any like terms. Now, I'm going to skip over to these here. X squared of 5, negative x squared of 5. There you go. Negative 2 squared of 5, positive 2 squared of 5. All of our radicals are gone. That's why we do these first. Because now we don't have to worry about radical terms. And it would always go away even if you'd have done the x minus 3 times our x minus 2 minus the square root of 5. But you have to hold on to those radical terms until you multiply with its conjugate. So it's better to just multiply the conjugates, get rid of them first, then multiply with our other terms. Now our negative 2x minus 2x is negative 4x. Positive 4 minus 5 is negative 1. Yep. We have one last multiplication and we're done. I'll finish this up, then you can go. Distributing the x times x squared is x. X times negative 4x is negative 4x. And x times negative 1 is negative x. We'll do the same thing with negative 3. Negative 3 times x squared is negative 3x squared. Negative 3x, or negative 3 times negative 4x would be plus 12x. And negative 3 times negative 1 plus 3. And x squared plus 11x. And that's it. You're welcome. Number 6 is, you're good. The number that is written in is 224. I wrote it in already.
Yeah.
But
That's correct.
yes. I went on and fixed it because the number I had originally would have made everything worse. Yes. Okay. Because you returned 7, yes?
Yes.
Okay. I was just making sure. Yeah, because I had you down with 7. Yeah. Okay. Questions on this here?
They canceled them on Friday? That's what...
The 7 and the last 2.
Oh, so wait, someone told me they canceled. They probably did, but not...
The last 2, the 7 and 8:30, whatever the last 2 games were, got canceled. But we have the early 2.
You are?
I'm a bench warmer though, don't worry.
No, I just saw you like walk out there one day, like up to the.
Questions on how we do this here? We feel comfortable with these here? Do we want to see another one of these?
Can we see one where like... Oh, okay. I just don't know where to start.
So the first 3 rational zeros are plus or minus p over q. Okay? So where we started this one here, so x equals 4, x equals -3, x equals the square root of 3, is kind of the first step we had on the last one. So instead of telling us the zeros are this, they already listed it out for us. So we know those 2 are true. Since x is equal to the square root of 3, x is also equal to. Now at this point here, we need to get all 4 of these equal to. So the first one we can subtract 4, telling us x minus 4 is equal to 0. For the second one, we're going to add 3, telling us x 3 is equal to 0. For the next one, we would subtract the square root of 3, telling us x minus the square root of 3 is 0. And for the last one, we would yes. Well, yes and no. According to the irrational zeros, or our irrationals conjugates theorem, if we have 1, so we have the square root of 3 as a solution, its conjugate, so we just change the sign in front of the radical, is also 1. Because those are not irrational. Are radicals that don't reduce. Now at this point here, we're going to multiply all 4 of them to, yeah. Yes. Yeah, there's nothing that says we can't do our x minus 4 times x minus 3, have it as one set of parentheses, then do the other. Because if we did this, x times x would be x squared, x times 3 would be plus 3x, negative 4 times x would be negative 4x, and negative 4 times 3 would be negative 12. And the other set of parentheses, x times x is x squared. X times the square root of 3 would be plus x square root of 3. Negative square root of 3 times x is negative x square root of 3. And negative square root of 3 times the square root of 3 would be negative. Because inside radicals, whenever we multiply 2 radicals, we multiply the number inside. 3 times 3 is 9. Square root of 9 is 3. So instead of writing the square root of 9, we know what the square root of 9 is, 3. Combine like terms. For our first one, it'd be 3x minus 4x, which is negative x. Second, we'll have x squared, but our x squared of 3, negative x squared of 3 are gone. That's 0. Last thing we need to do is distribute out x squared times x squared is x to the 4th. X squared times negative 3, negative 3x squared. Negative x times x squared is negative x cubed. Negative x times negative 3 is plus 3x. Negative 12 times x squared is negative 12x squared. And negative 12 times negative 3 is plus 36. When we combine like terms, we'd have the x to the 4th minus x cubed minus 15x squared plus 3x plus 36. And that's the final answer.